Welcome to class. Today we are on second part of sequences and functions, and today we are going to learn how to find the nth term. Now, we learned about the types of type of sequences, whereby we learned about linear sequence and non-linear sequence. And the linear sequence can also be called an arithmetic sequence, and you can write the position of the term rule. Remember, we also learned about two types of rules: position term rule, position to term rule. The other one was term to term rule. So today we want to apply the other side to our time. We saw how we apply these two in a linear sequence, and today we want to see how we are going to apply position to term rule on an arithmetic or linear sequence, and we can find out the term which we do not know, as I already explained in the previous subtopic, called the nth term. For example, you can be given the term below, and you have 8, 11, 14, and 17. Now, what you are going to do, 11 minus 8, that will be 3, 14 minus 11 will be 3, 17 minus 14 will be 3. So you can notice that each time there's a difference of 3. There's a difference of 3. So that difference, you write it as 3 there. After writing that 3 there, then since we are living in the nth position, then we write as n. So that is a 3n. So after writing 3n, that's our part. Then you see what we can add or minus in order for us to have a term position to term rule. And in this case, you add 5. Now, if you add 5 to 3n, you can't find any member of this sequence. For example, when n is 1, 2, 3, 4. Now, suppose that n is 1. So when n is 1, you take 3 times 1, which is the number n, plus 5. So 3 times 1 will be 3, plus 5 will be 8. These are the first term here. When n is 2, you will be taking 3 times 2, which is 6, plus 5, which will be 11. Which can be with this one. Then when n is 3, you take 3 times n, which is 3, plus 5, which will give you 14. When n is 4, you take 4 times 3, which is 12, 12 plus 7 will give you 12 plus 5 will give you 17. So this is how you can do this one. Now, the position can be represented by n. Therefore, the position term rule can be written as 3n plus 5. I'm going to show you in the next coming minutes on how you can get this value, what to add and what to subtract. What you add and you subtract, I'm going to show you in a while how to do it. And this is called an expression for the nth term. Now, if you are asked to find the expression for the nth term, so this is the expression for the nth term. Now, suppose that we have that one, then this is what we are doing. We are going to come on. Now, if you have a table like this is n, where n can be 1, 2, 3, 4, 5, 6, and 2. Whatever the value you are interested in. Then the terms, and what you are going to get, they are when you use the term you've been given, or rather, when you are given the term rule. So you can use the term rule to find this one. So whichever term rule here is 3n plus 5. So you can use 3n plus 5, whereby it is 3. So we can find 3n, whereby when you have 3n plus 5, you can work out 3n, for which when n is 1, 3 times 1. When n is 2, is 3 times 2. When n is 3, 3 times 3. When n is 4, is 3 times 4. So 3n will be 3 times n for each and every section. So after you gotten your n, then you are going to add 5. So our n, which is this one, plus 5, which will give us 8. Our n, according to this one, is 6 plus 5. Our n here is 9 plus 5. Our n here is 12 plus 5. So that is how. So you will notice that the value you find here is the same as the value you find there. In other words, this is the term expression. It's going to give you this value which are the same as this one value. Now, so what example? Example number, that term of a sequence is 6 minus 2n. 6 minus 2n. Work out the first term and the 10, the first 3 terms and the 10th term of the sequence. Now looking at this one, so assume these terms are not there. This is exactly what I'm interested in. So your table will be comprising of n. You see the past for term, you're going to work out the term, then 2n, then 6 minus 2n. Now in this case, our n will always begin at 1, 2, 3, and it can even go to 1,000, 100,000. Now our 2n, it will be this 2 times n. So it is 2 times 1, because here our n is 1. Then for 2n, it will be 2 times 2. Then in this case, our n is 3, so 2 times 3. And in this case, our n is 10, so it is 2 times 10. So we need, here we need 2, here we need 4, 6, and here we need 20. Now 6 minus 2n. So 6 minus 2n. We found at this point our 2n is 2. So 6 minus 2 will be 4. At this point our 2n will be 4. So 6 minus 4 will be 2. At this end, our n will be 6. So 6 minus 6 is 0. At this end, our 10n will be 20. 2n, sorry, 2n will be 20. 6 minus 2n is 2. And if you look at these values, they are the same. This and this, this. Now, that is how we do that. Now, to our example number 2, work out the expression for the n term of the sequence. Now, I want you to find, I want to teach you how you can get the term rule. The term rule. The term rule is what I'm going to teach you how to get now. Now, we have 6, 8, 10, 12. So, 6, 8, 10, and 12. Now, if you look at this one, the difference between 8 minus 6 is 2. 10 minus 8 is 2. 12 minus 10 is 2. So there's a difference of 2. You take the second number minus the first number, second number minus first number, second minus first. So when the answer you get is positive, then n becomes positive. When, for example, you get this one to be negative, I'm going to show you that, then the n is 1. So the difference is 2. So we are going to begin with 2n. We are going to begin with 2n. Now, after getting 2n, our first, so here, there, we are going to get 2n. So our first term here is 6. So we are going to say 2n. We have 2n as the expression, of which this is n stands for the position. So 2 times 1 is equal to how many? 2. 2 times 1 is equal to 2. Now for us to get what we have to add into this 2n, we take the first term minus what we have gotten for 2n. Let me repeat. The difference between this and this is 2. And because we are minusing the second one minus first, second minus first, second minus first. We have a linear, therefore it will be 2. The difference is 2. That's 2 you multiply by n. After multiplying 2 by n, what do you do next? The first term is that one. So, this is the first position, second position, third position. So for the first term, 2 times n, which is our ns1, which is equal to 2. Now for us to find how many we are supposed to add, we just take the first term minus what we put in here. So 6 minus 2 is equal to what? 6 minus 2 is equal to 4. So in other words, we're going to take our 2n plus 4. Okay. So this is going to be the expression. This is going to be the expression. Now if you use this term rule, this is the term rule. If you use this term rule, you can get any value you want. To prove that, here we have the term rule. So I'm calculating the value of n, 2n here. I'm getting the value of 2n. Then here is 2n plus 4. 2n plus 4, you are going to get 6, 8, 10, and they are going to be like that. So that is what happened. Now we are going to stop there for the first part. Then we are going to come back to the second part in calculating example 3. Thank you.